Geometric sequence is another type of number pattern with a slightly different way of generating terms. Learn about it here in Mathematics of Engineering. In geometric sequence, the next term is generated by multiplying a constant to the current term. Such constant is called common ratio. For the first sequence, 6, or the second term, is computed by multiplying 2 to 3. The procedure continues to the third term, which is the common ratio 2 multiplied by the second term 6. Then the process continues. For the second example, the common ratio is taken as 4/5. So, 100 multiplied by 4/5 is 80. Then 80 times 4/5 is 64. Again, the process continues to the succeeding terms. Next is for us to understand how to take the explicit formula of a geometric sequence. If the pattern is a geometric sequence, they are related by r by multiplication. So a sub 2 is the initial term times r. The third term is also taken as a sub 2 multiplied by r, simplified as a sub 1 with r times r, or that is a sub 1 times r squared. Using the same procedure, a sub 4 is then computed as a sub 3 times r, simplified as a sub 1 times r squared times r, making it a sub 1 r cubed. By having all formulas, notice that the explicit formula for geometric sequence is a sub n is equal to a sub 1 multiplied by the common ratio r raised to n minus 1. Let's practice using the explicit formula with the first example, which is looking for the first 4 terms of a geometric sequence if the initial term is 10 and the common ratio is -1. We can show this with a sub 1 identified as 10 and a sub 2 until a sub 5 are required. Using the explicit formula, we can directly solve for a sub 2 as a sub 1 multiplied by r raised to 2 less 1. By plugging a sub 1 as 10 and r as -1, a sub 2 is solved as -10. A sub 3 is computed as 10 times -1 raised to 3 minus 1, or that is -1 squared, which gives +10. A sub 4 follows the same track, giving 10 times -1 raised to 4 less 1, making it 10 times -1 cubed, which is -10. Then lastly, a sub 5 is also solved the same way, which becomes 10 times -1 to the 4th power, which is equal to +10. With the geometric sequence provided in example 2, it is required to determine x. The way for us to correlate the terms in the sequence is when we compute for the common ratio. Thus, r for the first and second terms is x plus 12 all over x plus 6. And the r for the second and third terms is taken as a ratio of x plus 15 and x plus 12. So by equating the common ratios, we have x plus 12 all over x plus 6 is equal to the ratio of x plus 15 and x plus 12. By cross-multiplying the terms, we have the quantity of x plus 12 with the quantity of x plus 12, and this is equated to the quantity of x plus 6 times x plus 15. Multiply quantities to get x squared plus 24x plus 144 is equal to x squared plus 21x plus 90. Cancel out x squared on both sides of the equation, and collect terms with x on the left side while placing all constants on the right to have 3x is equal to -54. Now, Isolate x by dividing everything by 3, and we end up with x equal to negative 18. Example 3 is solved easily even without a sequence provided. It states, find the common ratio of the general term of a geometric sequence a sub n is equal to 7 all over 11 of a sub n plus 1. Using the explicit formula, we can equate r with a sub n plus 1 all over a sub n. Then substitute a sub n from the given to have r equal to a sub n plus 1 all over 7 all over 11 of a sub n plus 1, where the term a's are cancelled out to have r equal to 11 out of 7. Example 4 requires us to determine x and y from the geometric sequence. If we plot the sequence and check on the common ratio, we end up with 3 equations, which can be complicated. So we would focus on the geometric extremes, as they are both constants, and we use the explicit formula to look for the common ratio. A sub 4 is a sub 1 times r raised to 4 less 1, or that is, 64 is equal to 1 times r cubed, where r comes out to be 4. Knowing the common ratio, we identify x through the explicit formula using a sub 2 as a sub 1 times r raised to 2 less 1. That is, 4x is equal to 1 times 4 raised to 1, or simply 4. Then we divide everything by 4 to have x equal to 1. For y, we use a sub 3 equal to a sub 1 times r raised to 3 minus 1, which is 4y is equal to 4 squared. Isolate y by dividing the equation by 4 to get y equal to 4.